are Team Krogang. Welcome to our final report. For question generation, we first apply co-ref resolution to the article using spaCy, and then process each sentence using stanza, because unknown texts generated by special symbols are not accepted by stanza. So we decided to process on a sentence level instead of article level, so that we can skip a sentence if stanza failure occurred. For each processed sentence, we then generate binary and WH questions based on constituency parsing and NER tags. And then we rank all generated questions using perplexity given by the GPT-2 model. Applying coreference resolution in the pre-processing stage greatly improved the quality of our generated questions, because questions generated from sentences that only contains personal pronouns and possessive pronouns have ambiguous references. But instead of using sophisticated coref library like NeuroCoref, we decided to implement our own coref by assigning the last seen word with person tag to each PRP and PRP possessive. Because of the inaccuracy in our coref algorithm, it actually made our questions diverse and be able to contain false information. After all, questions are not supposed to be always true, so inaccuracy is a good feature here. To rank our generated questions, we first decided to generate 4 times n questions for selection and efficiency. We initially tried CFG using NLTK, but quickly discovered it's too naive and doesn't work well with limited CFG defined by us. And we recall that perplexity is the average branching rate, meaning the lower the perplexity of a sentence, the more likely it occurs commonly in grammatically correct contexts, and thus be more correct itself. So we choose to rank sentences based on perplexity using a sophisticated language model, GPT-2.
For answer part, we first classify question into 3 categories. Then we need to localize the answer using TF-IDF and cosine similarity. After determining the validation of question, the answer can be generated. The questions can be classified by the first word of each sentence as shown following. Noteworthy, the word whom is classified in the who, when, where category. For localizing answer sentence, our goal is to find potential sentences that may include the answers. First, we initialize a vectorizer that removes English stop words. Then we create a corpus of query and documents that convert to TF-IDF vectors. Use the first vector as our query text, and the cosine similarity can be computed with the query against all document TF-IDF vectors. The similarity score and sorted and return the top several highest score sentences. Higher rate sentences are potentially including the answer. For binary question answer, we initially tried randomly generate yes or no answer, since they are the only two and determined answer. Then we have localized our answer sentence, determine whether the question is valid through its length. We compare the question sentence with the selected sentence that may potentially have our answer. If the entity is included in the selected sentence, we return output as yes and no otherwise. For WH question answer, we've also find potential sentence first, then compare question sentence with selected sentence and see whether the entity is included in select sentence. The final answer will be generated by the non-existing entity and return can't find answer otherwise.
Let's go in details on question generation. To solve the question task, we begin with a constituency and dependence analysis. This is a graph to analyze the constituents pardon, and we can see that there are significantly more NPVP constituents than others, and there are also a lot of PP and PVP. So we can generate a question based on the pardons and text accession and preprocess. So when we're generating the text, we encounter a few problems with stanza. And so the first problem is that the title credit section has little to ask. And the solution is that we eliminate the sentence has no ending mark or no VP. And the second problem is that the text constituents reorders in stanza, and we sometimes encounter illegal character called stanza to file. And the solution is that we change the whole file parsing to sentence parsing sentence by sentence. To generate the binary question, we first analyze constituents parsing tree on each sentence, and then choose the leading word based on the verb phrase in the sentence. So auxiliary verb have leading words like is, are, and modal verb have can, show, well. And we can form question with format in the slides. And to generate the who and where question, we first analyze constituency parsing and select sentence that is relatively easy to generate good question. We then choose the question type based on the entities in the sentence. For example, if we have a person in the entity list, we will ask a who question. Then we generate a question based on constituents. To ask a question about NP, we can follow the first format, and to ask about the question about PP, we can follow the second format.